Example 1 involves the simplification of a power expression. This is the step-by-step order in which you should do it if you want it to be the easiest possible problem possible. You have to know how to be able to multiply, add and subtract, and you have to be able to determine what number is bigger, and you have to be able to identify negative numbers. I can't make this any simpler than this, but I just want to make sure you understand every letter affects every letter of the same type. X's do not affect Y's, Z's do not affect V's, whatever. So different letters don't affect each other. And if there's numbers involved, numbers to powers equal whatever they equal. So if there's like 2 to the third power, that's 8, because that's what 2 to the third power equals. If it's x squared to the third power, that's x to the 6th, because that's what this rule says. And let me focus right now on rule 2, because this is the new thing. This is what we've never done before. Okay, put the step 1, write the problem on your paper. Put 1 powers anywhere there is no power written. If you see this structure, a parentheses object to another power, every power inside multiplies by every power outside to make the new power. So if this is, for example, x to the 3rd to the 5th, that becomes x to the 15th power. You multiply the 2 powers together. If it's 2 x to the 3rd to the 3rd, that's going to be 8x to the 9th, because 2 cubed equals 8. Okay, don't do 2 times 3 equals 6. This is 2 to the 1st. So the base is 2, 1 times 3 is 3, and 2 to the 3rd equals 8. All right, so if there's a number in there, you're just going to get the numerical evaluation there. Once you've done that, any negative or 0 powers should be moved. Do that after you do this. Get rid of all parentheses first, then move negative powers, and 0 powers can be struck out. Times 1 doesn't do anything. Multiply common bases on top and bottom separately. So if there's a bunch of x's on top, multiply them together. A bunch of x's on the bottom, multiply them together by adding powers. And finally, divide common bases, determine where the answer should be, the higher power, and then subtract big minus small power to get what the power of the answer is. And as I've always said on these problems, and I'll continue to say it, and at some point some of you will believe me, do not put negative powers in final answers no matter what the book tells you to do. I'm grading your papers, the book isn't. I do not want negative powers in final answers ever.
Sometimes the book does tell us to do it.
Because what?
Sometimes the book does tell us to.
Yeah, sometimes it tells you to use negative powers. Don't listen to it. Leading you astray. All right, so example 1, simplify this. So again, step 1, if I'm doing this on my own paper, I'm going to put a big parentheses, 3 to the 1st, x to the negative 2nd, y to the 5th, over z to the 4th, to the negative 2nd power.
It's negative 3rd. On our paper, it's negative 3rd power.
Yours is negative 3rd power?
No.
I just copy and pasted it.
Oh, I was going to
All right,
practice on it.
there you go. All right. So is everybody on the right side of the paper now? Okay, here we go. Continue. Now, what this rule says, let me just make sure that we understand, because a lot of times algebra rules mess people up a little bit. Focus on structure and what things are. X is the base, M and N are powers. We're supposed to multiply the powers, keep the base as is. Looking at this thing that I've got here, the bases are 3, x, y, and z. So notice the bases are going to stay 3, x, y, and z. I haven't put the correct powers on them yet. I'm going to drop the parentheses also. So the bases do not change when you apply this rule. When you have a power structure to a power, the bases stay the same. The powers multiply for each base. So 1 times negative 2 is negative 2. Negative 2 times negative 2 is positive 4. 5 times negative 2 is negative 10. 4 times negative 2 is negative 8. Okay? So again, when you have a power structure in parentheses raised to a power outside the parentheses, every base remains the same. All the powers get multiplied by this number. Negative 2, positive 4, negative 10, negative 8. The reason I don't deal with negative powers in the first step is because this was the only negative power and now it's the only positive power. Sometimes powers become positive just because of multiplication. So never deal with negative powers until you get the parentheses out of the problem. Step 2. Every negative power needs to move. Every positive power stays where it's at. So these 3 things move. The x to the 4th power stays where it's at. So I would rewrite x to the 4th power. On the bottom, I'm going to move the 3 squared down. I'm going to move y to the 10th down. And I'm moving z to the 8th up. So the 3 things in green there got moved. Once I moved them where they belong, the powers became positive. when you move things, the base moves with the power. So 3 is the base, moves with the negative 2 power to the bottom, 3 to the positive 2 power. Z is the base, the negative 8 power moves to the top, Z to the positive 8, Y to the negative 10 moves, Y to the positive 10. X to the 4 stayed right on where it was on top. Doesn't matter about order of things. I put X there, I could just easily put X to the 4th after Z to the 8th. As long as these are on top, those are on bottom, you got them in the right places. On step 4, multiplying common bases, this is the place where I would actually evaluate numbers also. So, looking at this, X and Z are different, Y is different, there's no common letters, so we don't have that issue to deal with, but 3 squared equals 9. I do want all numbers evaluated, so X to the 4th, Z to the 8th on top, 9Y to the 10th on the bottom. But again, X and Z are different, Y is different, so I can't multiply those, I can't multiply those. Step 4 basically doesn't happen except for the evaluating the 3 squared. Step 5, if I have the same letter on top and bottom, which I don't, I would have to divide. I can't do anything else to that problem, so that's the best answer possible. You're done when there's one of each type of letter and all the powers are positive and all the numbers are evaluated. That's when you're done with the problem.